Hello and welcome to today's lesson on dilutions. So dilutions are something we use all the time. Uh, and when we make dilutions, and we do this a lot in science, is we typically use a concentrated stock solution and then we dilute it out to a concentration that we want to work with. For example, hydrochloric acid comes in a 12 molar stock solution. Most of what we do in lab doesn't use a 12 molar stock solution. And so we take a concentrated solution and we dilute it down. For example, if we have a 1 molar solution, we can dilute it down to 1/10 of that and end up with a 0.1 molar solution. And the important thing to remember and to note is that when you dilute something, you're not changing the amount of solute. So your amount of solute stays the same or does not change. The only thing we're changing, the way we dilute something, is to add water. So in the case of our molarity equation, M equals N over V, what we're changing with this is we're changing the volume. Because if you divide by a bigger number, so for example, let's say I had 2 moles, just for number's sake, I have 2 moles of a substance. That's really poorly written. If I have a volume of, let's say, 10 liters, let's say 0.1 liters, 0.1 liters. My concentration is going to be 2 divided by 0.1, which is going to be 20 molar, which is very concentrated. Now let's change that volume. Let's make that 10 molar, or 10 liters. So now if I have let's make it 1 liter. If I have 2 moles, I divide it by 1 liter. My concentration is now only 2 molar. And you'll notice the thing that we changed was this volume. We changed my liters. The thing that stayed the same in both cases was my moles, my amount of substance. And so because of this, we can kind of make a new equation for all of it, or we can merge the equations, and I'll show you that here in a second. The last question at the bottom. How many milliliters of a 1.0 molar solution are required to make 200 milliliters of a 0.3 molar solution? So we set up above that your moles stays the same. In order to calculate moles, you're going to take molarity times the volume. So with M equals N over V, if I'm solving for N, because that's got to stay the same, I'm going to take my molarity times my volume. In this case, I have a 1.0 molar solution, and I have 200 milliliters of it. So I know that N is going to be, my moles are going to be equal to 1.0 molar times my volume's got to be in liters in this case, which is going to be 0.200 liters. 1 times 0.2 is N equals 0.20 moles. And I want to know what volume, how many milliliters are required to make a 0.3 molar solution. So if my solution has to be 0.3 molar and I have 0.20 moles, I know that M is now equal to 0.3. I know N is 0.2 moles, and I'm looking for V. So we can take my M equals N over V, and we can solve it for V. And so we're going to get V equals N over M. And so I'm going to get V equals, let's go here. N is 0.2. Uh, 0.20 moles. And M is 0.3 0.3 molar. And if I take 0.2 divided by 0.3, I'm going to get an answer that is 0.666 repeating. This means my volume, instead of being 200 milliliters, is now going to be, that's going to, so 0.67 liters, or 670, that's a 6 milliliters. So we're going to look at another one of these on the next slide, and we'll do some practice here. Okay, so the question is, what volume of 16 molar sulfuric acid must be used to prepare 1.5 liters of a 0.10 molar sulfuric acid solution? Okay, so you notice you have two molarities. You have M1, which is what you start with, which is 16 molar, and you have M2, which is what you want to end with, which is 0.10 molar. In this case, I'm looking for volume of my 16 molar solution. So I'm looking for V1 because I don't know that, and I have a V2, which is 1.5 liters. Notice you have, for our equation, N over V. In both cases, I have a molarity and I have a volume, and I don't have moles. But I can solve it for N. So to get N by itself, we're going to take N equals M times V. In this case, I have my first molarity and my first volume. I also have this same N is going to be equal to my M2. And so I can solve this one, and I can get N equals M2 times V2. This makes dilutions really simple. That your molarity, I can take both of these, and because they're both equal to N, I can set them equal to each other. So I can get M1 times V1 equals M2 times V2. And then I can just plug in numbers and cross multiply and solve, or divide and solve. So we have M1 is equal to 16 molar. Oops. Let's do 16 molar times, and I don't know V1, so I'm going to put times V1 has to be equal to M2, which is 0.10 molar, times 1.5 liters. So if I take 0.1 times 1.5, I'm going to get 0.15 on this side. And I would have molar liters for my unit. On the other side, I still have 16 molar times V1. And to get V by itself, I'm going to divide by 16 molar. I'm going to divide by 16 molar. And you'll notice this will cancel out my units there. So if I take 0.15 divided by 16, this is going to give me a V1 of 9.38, 9.4 times 10 to the minus third liters. Okay, so what this is telling me is that I need to take 9.4 times 10 minus third liters, or 9.4 milliliters, if I'm going to make this a little bit easier on me. So I need 9.4 milliliters of my 16 molar solution. Okay, I need 9.4 milliliters of my 16 molar solution. And then to get to my 1.5, I'm going to take 9.4 plus X equals, and I'm going to make it all milliliters, so 1,500 milliliters. And so I'm going to need 9.4 milliliters of H2SO4, and I'm going to need 140.6 milliliters of water. That's going to be how we get this solution. So we took 9.4 milliliters of sulfuric acid and added 140.6 milliliters of water to make my 1.5 milliliter solution, or 1,500 milliliter solution. Hey, here's another one. It says to calculate the new molarity that results when you dilute 25.5 milliliters of a 14.9 molar solution of nitric acid to a final volume of 1 liter. So here we go. Write down the things, underline, and write down the things we know. I know, oops, let's go back. Apologize. I missed my pen. So I know I have 25.5 milliliters. I have 14.9 molar solution, and I have a final volume of 1 liter. So my units need to be the same. So M1, we have 14.9. V1, we have 25.5 milliliters, and V2, we have 1 liter. So remember, units have to be the same here. And I'm looking for M2 because I don't know what that is. So in this case, I'm going to make my 1 liter into 1,000 milliliters. Just, you can do either. I'm going to go that route. So now I have M1, V1. I have V2, and I'm looking for M2. So I have my equation, which is M1 times V1 equals M2 times V2. And because we're setting up this way, I can go to milliliters. As long as my volume's in the same units, it doesn't matter if it's liters or milliliters or kiloliters or microliters. It's just got to be the same unit. So here I have 14.9 molar times 25.5 milliliters equals 1,000 milliliters times M2. So I'm going to multiply these two and then divide by my 1,000 milliliters. And on this side, my milliliters are going to cancel, so I'm left with molar. So if I take 14.9 times 25.5 and then divide that by 1,000, I'm going to get a V2, or an M2, sorry. My apologies. I'm going to get an M2 of 0.3799 or 380. So I have 0.380, and I have to put my units at the end, and that's molar. So there's another example there. If you would like to practice, here's a chance for you to practice and look at what volume is required. So we have concentrated H3PO4, which is phosphoric acid, has a concentration of 14.8 molar. What volume of this would be required to make 25 liters of 0.5 molar phosphoric acid? So you're going to set this up the same way, solve it the same way. I will post the answers on my website so you can have a chance to see if you're doing it correctly. Otherwise, I will talk to you guys tomorrow, and we will continue practicing with this. Let me know if you have questions, and have a good day.